Hi, grade 10s. It's Mr. McLeod here. I just make a quick video, tell you about these things called quadratic relations, and tell you a little bit about the shape they make, which is called a parabola. Okay, we got a table of values here. We're going to complete this. We have a relation y equals x squared minus 2x minus 3. We actually already know that this is a quadratic relation because we have an x squared in it. Any relation where you have y equals and then it has an x squared as the variable with the highest exponent is quadratic. We call this polynomial degree 2. Okay, so we're going to take these x values one at a time, sub them in for x, and then we'll see what kind of points we get, and we'll plot them on the graph. If you have the opportunity to print this sheet out, that would probably be the most helpful. If you don't, it'll probably be okay just to watch, and it'll be fairly simple. Okay, so actually I'm going to start with x equals 0. If x is 0, then, well, 0 in for x, 0 squared is 0. And negative 2 times 0 is 0 minus 3. So when x is 0, y is equal to 0 minus 0 is minus 3. Okay, 0 and negative 3. So that's our point here, 0 and negative 3 right there. Okay, let's go with the next point, which is 1. If x is 1, 1 squared is 1 times 1, which is 1, minus 2 times 1 is 2, minus 3. So when x is 1, y equals 1 minus 2 is negative 1 minus 3 is negative 4. So we have 1 and negative 4 is our next point. So 1 and negative 4 is right there. All right, next point. If x is 2, subbing in 2 for x, we have 2 squared, which is 4. And negative 2 times 2 is minus 4, and then minus 3. So when x is 2, we have 4 minus 4 is 0, minus 3 is minus 3. All right, so the next point is 2 and negative 3. So here's 2 and negative 3. Okay, the next point is when x is 3. So y equals, when x is 3, 3 times 3 is 9, minus 2 times 3 is 6, minus 3. So here we go. 9 minus 6 is 3, minus 3 is 0. So when x equals 3, y equals 0. So here we go. X is 3, 1, 2, 3, and y equals 0 right there. Okay, the next point is when x equals 4. We put in 4 for x. 4 squared is 4 times 4, which is 16. Minus 2 times 4 is 8. And then minus 3. So here we go. 16 minus 8 is 8. Minus 3 is 5. So when x is 4, y equals 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, so those are the positive values. Let's move on to the negative values next. All right, when x equals negative 1, here we go. Negative 1 squared is negative 1 times negative 1, which is 1. And when x is negative 1, negative 2 times negative 1 is a positive 2. And then we have negative 3. So 1 plus 2 is negative 3. Oh, sorry, 1 plus 2 is 3, minus 3 is 0. So when x is negative 1, y is 0. X is negative 1, y is 0. And the last point here is x is negative 2. Okay, if x is negative 2, negative 2 squared is negative 2 times negative 2, which is 4. And minus 2x, so minus 2 times negative 2 is positive 4, minus 3. And so we have 4 plus 4 is 8, minus 3 is 5. So when x is negative 2, y is 5. Here's negative 2, y is 5. 1, 2, 3, 4, 5. Okay, now we can draw a smooth curve through the dots. And here is what our graph looks like. I'll start down here. We draw a smooth curve. And it forms this kind of U shape that is called a parabola. Okay, so now we're going to go over some of the features of this parabola. This parabola, we can say it opens up. That means that on each end, on the left and right, it keeps going up and up and up forever. Parabolas can also open down, which will make it look like an upside down U, I guess. So an up parabola looks like this, and a down parabola looks like this. Now my last post had you working on calculating second differences from a table. And you'll know that when the second differences are all the same or constant, then the relation is quadratic and forms this parabola shape on the graph. If those second differences are all positive, then the parabola will open up. And if the second differences, when you calculate them, they're all negative, let's say negative 3, negative 3, negative 3, negative 3, then that tells you that the parabola actually opens down. Okay, the next really important feature of a parabola is something called the vertex. If we go up here, we know that there is a definite lowest point of the parabola, which is right here. And this is called the vertex. And a lot of future problems will have us finding the coordinates of this vertex. So from the graph, it's easy to tell the coordinates of the vertex because you can just read the coordinates right from the graph. So this vertex is located at 1 and negative 4. If the parabola opens down, like this one does, then the vertex represents a high point of the parabola, kind of a maximum point, if you will. And if the parabola opens up, it represents a minimum point. So maybe I'll write that down here. Minimum. And if the parabola opens down, it reaches a maximum at the vertex, and then goes back down. Okay, along with the vertex is something called the optimal value. So the optimal value is basically the y-coordinate of the vertex. So whatever y-coordinate it gets down to is called the optimal value. So in this case, the optimal value is y equals negative 4. Whoops, I messed up over here. 1 and negative 4. The y value is negative 4. This parabola can be said to have a minimum value of negative 4. Okay, so minimum or optimal value of negative 4. Okay, the next big thing is something called the axis of symmetry. as you can see, the parabola is symmetric left and right. You can tell from the table of values that the y values start to repeat, which means it's symmetric. So there's an imaginary line about which this parabola is symmetric. If you drew this parabola on a piece of paper and folded it down this green line here, then both sides of the parabola would match up. And this is called an axis of symmetry. Axis of symmetry. Symmetry has two M's, I think. Okay, and then we can define this axis of symmetry. Notice that it crosses the x-axis at some point. So we can say that the axis of symmetry, in this case, is defined by x equals 1. That's the x value that the axis of symmetry passes through. And notice that it also corresponds to the x-coordinate of the vertex. The vertex is also located on the axis of symmetry. All right, one more main feature of the parabola, and that is the x-intercepts. So you'll notice that the parabola crosses the x-axis at, in fact, 2 points, since the parabola comes down and then goes back up. So these are the x-intercepts. X-intercepts. And a lot of times a parabola will cross the x-intercept, the x-axis twice, and we can identify where those points are. So this x-intercept is -1. So x equals -1 is one x-intercept, and the other one is 1, 2, 3, x equals 3. Those are the x-intercepts where they cross. And sometimes we'll have to identify those. Now it says here, parabolas can have 2 or 1 or 0 x-intercepts. Well, let's look at those three different cases. So for a parabola to have 2 x-intercepts, well, you could have a parabola that opens up where the vertex is below the x-axis, like this. So there's 2 x-intercepts. The vertex could also be above the x-axis and the parabola opens down. That would create 2 x-intercepts, 2 places where the parabola crosses the x-axis. The parabola could also have no x-intercepts, so it could open up, but the entirety of the parabola could be above the x-axis rather, and it doesn't cross the x-axis at all. Or, of course, it could open down but be below the x-axis, and again, it would have no x-intercepts. And a third possibility is this: the vertex could be located right on the x-axis, and maybe it opens up or opens down, but the parabola comes down and just touches the x-axis in one spot and goes up. And we say that that parabola has only one x-intercept. So that is just a few things about parabolas that we're going to be talking about over the next little while. Hopefully that made sense, and hopefully you're able to write some of that down.